When we make a decision under uncertainty, sometimes we don't have enough information to calculate the probability of future scenarios. In these cases, we have to go about making the decision using different methods. The first method that we learn is called Laplace criterion. In Laplace criterion, or insufficient reason, we assume all the future events have the same probability of happening. Therefore, if we have n events that are possible to happen in the future, the probability of each of them happening is going to be 1 over n. After associating these probabilities to future events, we can calculate the expected value of each alternative and pick the alternative with the highest expected value. This example shows how we can use Laplace criterion. This is the same example that we earlier saw, with the difference that we don't have probability of each event in the future. Previously, we had 20%, 30%, and 50% for the probability of C1, C2, and C1 and C2 together, but now we don't have those probabilities. So basically, we assume each event has the same probability of happening. Since we have 3 events, we assume the probability associated with each of them is 1/3. Therefore, you can calculate the expected value of all these alternatives, and you can pick the one that has the highest expected value for us, which in this case is A3. Alternative 3 is selected to be the best alternative. Second method of making decision under uncertainty when you don't have probabilities for the future events to happen is maximean or maximax criteria. In maximean criteria, which is a pessimistic approach, we actually pick the alternative that provides us with the best worst case scenario. So we find the minimum outcome from each alternative and find the maximum of those values, and we see what alternative is associated to that maximum. When we get to an example, this seems to be much easier than in definition. In maximax criteria, we try to find the best case scenario of best possible outcomes, and that's why we call this an optimistic approach. So let's look at this example that we saw earlier. We saw that there are probabilities associated with them in the past, but now assume that we don't have these probabilities. And the way that we want to solve this problem is maximean, that basically we're trying to be pessimistic a little bit about making our decision. So from each of these alternatives, we have to pick the minimum outcome. So 100 is the minimum outcome for alternative 1, negative 200 for alternative 2, 0 for alternative 3, and 100 is for alternative 4. And minimum outcome doesn't have to necessarily fall into the same future event. So in this case, in the maximean, after we pick the minimum outcome from each alternative, we find the alternative with the maximum possible outcome. Basically, we try to find the alternative that has the best worst case scenario. So if I look at this case, you see A1 and A4 provide us with that option. So A1 and A4, if we go based on maximean scenario, are going to be indifferent for us. In the maximax scenario, the way that we go about solving the problem is we find the best outcome from each alternative, and in the end we find the maximum among those and the alternative associated with that. The best outcome from the first alternative is 400, second alternative 600, third alternative 500, and fourth alternative is 300. Now we have to find the maximum of these maximum values, which is associated to A2 with $600. So A2 becomes your selection in a maximax scenario. So as I said, in this case, we try to be optimistic. We find the best out of the best possible outcomes. The alternative that possibly provides us the best possible outcome. But as you see, it seems like maximean and maximax are the two sides of this spectrum. You're either very pessimistic or very optimistic. There is another method that is called Hurwitz method, which is a trade-off between maximax and maximean method. In Hurwitz criterion, we basically find a linear combination of the maximax and maximean method. If you look at this equation down here, you see that there is a coefficient of alpha to the maximum outcome from each alternative. So basically in this method, you find the maximum of each alternative, you find its minimum, and you associate some coefficient between the max and mean. For example, if I put alpha 0, then you're going to find the answer to the maximean problem, because when alpha is 0, this term will be eliminated and you're looking at the maximum of minimum outcome, which is the maximean method. When alpha is 1, then this term will be eliminated because 1 minus 1 becomes 0, and this term will be eliminated. And basically, you're looking at the maxi-max problem to find the best decision possible. But when you allocate anything for alpha, you're basically finding a weighted value of the two numbers. And the higher the alpha, the more optimistic you become, because the higher the alpha, you're allocating more weight to the maximum outcome as opposed to minimum outcome. So the value of alpha shows how much you're optimistic or pessimistic toward making your decision. The higher the value of alpha, the more optimistic you are. The lower the alpha, the more pessimistic you become. So let's look at an example that we earlier saw. So in that example, we saw for each outcome, we have to find max and mean. And in this case, we associated alpha of 0.2 for solving the problem. And this is a given information. There is a graph that also helps you to see how your decision is going to switch from one alternative to another, depending on the value of alpha. That graph is in your textbook, which I highly recommend you to take a look at. So in this case, if I put alpha equal to 0.2, I can calculate the linear combination of these two numbers and find the alternative with the highest outcome, which in this case is alternative 1. As you see, using Laplace method, maximin, maximax, and Hurwitz method leads to different outcomes or alternative selection. And what we need to do sometimes is to go about finding the alternative that has been repeated the most. So we go based on the consensus-based method. From Laplace criterion, we saw that A3 was selected. From maximin, we went A1 or A4. Maximax A2 was selected, and here, which with alpha equal to 0.2, we picked A1. Since A1 been repeated twice, maybe alternative 1 is the best alternative for us to go with in this situation. I want you to take a look at the exercise 41 in chapter 7 to practice your skills with different methods of decision making. Thank you for watching this video.